The heart and the great vessel, part 2. The heart and the great vessels. The heart slightly larger than clenched fist, يعني بقدر قبضة اليد, is a double self-adjusting suction and pushing pump, the part of which work in union to proper blood to propel the blood to all parts of the body. The right side of the right heart receive the poorly oxygenated venous blood from the body through the superior vena cava and inferior vena cava. It pumps it through the pulmonary trunk to the lung for oxygenation. The left side heart, called the left heart, receives the well oxygenated arterial blood from the lungs through the pulmonary veins, four pulmonary veins, and pump it into the aorta for distribution to whole body. So that the heart has four chambers, right and left atriums, right and left ventricle. The atrial are receiving chambers that pump the blood into the ventricle, and the discharging chambers, the synchronous pumping action of the heart to atrioventricular AV pump, right and left chamber constitute of cardiac cycle. The cycle begins with a period of ventricular elongation and filling called diastolic, and end with a period of ventricular shortening and emptying called systolic. The two heart sounds are heard with the stethoscope loop, which is meaning the sound as blood is transferred, sucked from the atrial into the ventricle, and dub, the sound where the ventricle expels the blood from the heart, so that the heart sound are produced by snapping shut of one-way valve that normally keep the blood from the following backward, meaning the blood comes from the atrium to the ventricle will not go back during contraction of the heart. The wall of each heart chamber consists of three layers. Endocardium is a thin internal layer, endothelium, and subendothelial connective tissue are which lining the membrane of the heart that also covered with its valve, means the valves and the muscle. Myocardium is thick helical middle layer composed of cardiac muscles. The epicardium is a thin external layer, mesothelium, formed by the visceral layer of the fused with the visceral layer of the cerebral pericardium. The surface of the heart. The heart has three surfaces: sternocostal anterior, diaphragmatic surface inferior, and the base of the heart called the posterior. It also contains the apex, which is directly downward, forward, and to the left. Now, the sternocostal surface is formed mainly by right atrium and right ventricle, which are separated from each other by vertical atrioventricular groove. The right border of the heart, the right border is formed by right atrium, while the left border by the left ventricle and part of the left auricle, apart from the left atrium. The right ventricle is separated from the left ventricle by anterior interventricular groove. The diaphragmatic surface of the heart is formed mainly by the right and left ventricle, separating from each other by posterior interventricular groove. The inferior surface of the right atrium into which the inferior vena cava open also from a part of this surface. The base of the heart, or the posterior surface, is formed mainly by the left atrium, into which four veins, called the pulmonary veins, enter it. The base of the heart lie opposite the apex. This view show you the borders, the right ventricle, left ventricle, the apex, and the main vessels, pulmonary trunks and aorta, superior vena cava, inferior vena cava, and the auricle of the right side, and the auricle of the left side, with the distribution of coronary arteries and veins. The apex of the heart is formed mainly by the left ventricle, is directed forward, downward, and to the left side. It lies at the level of the fifth left intercostal space, 3.5 inches from the midline, about 9 centimeters from the midline. In the region of the apex, we can hear the apex beat. It can usually be seen and palpated in the living patient. Note that the base of the heart is called the base of the because is the heart pyramidal in shape. We call it the base because the heart pyramidal. The base lies opposite the apex. The heart does not rest on its base. It rested on the inferior surface, on the diaphragmatic surface. The borders of the heart. The right border of the heart is mostly formed by right atrium. The left border formed by the left ventricle and the auricle of the left atrium. The lower border by the right ventricle and the right atrium. The apex is formed by the left ventricle. This border is important to recognize when examining the radiographic of the heart. Chambers of the heart. The heart is divided by ventricular septum into four, by vertical septa into four chambers: right and left atrium, right and left ventricle. The right atrium lie anterior to the left atrium, and the right ventricle lie anterior to the left ventricle. The wall of the heart is composed of cardiac muscle called myocardium, covered externally by pericardial serous pericardium, while the epicardium, and lying internally by endocardium or endothelial layer. Opening into right atrium. Superior vena cava open into the upper part of the atrium. It has no valve. Return the blood from the upper region, from the upper limb, from the head of the body and head. Inferior vena cava larger than the superior vena cava and open into a part of the atrium. It's guarding by a rudimentary valve but non-function. It retains the blood to the heart from the whole lower half of the body. The coronary sinus, which drain the venous turning blood from the heart wall, opening into the right atrium, secured between the inferior vena cava and the atrioventricular orifice. It's guarded by rudimentary, non-functioning valve. The right atrioventricular orifice lie anterior to the inferior vena cava, open and guarding by tricuspid valve. Many small orifices of the small veins also drain the venous to the heart right atrium. This is the inner wall of the heart atrium and tricuspid valve which guarding the atrioventricular valve. Fetal remnants بقايا الهارت of infancy. In addition to the rudimentary valve of the inferior vena cava, there is what we call fossa ovale and annulus ovale. This latter structure lie on the arterial septum which separate the right and left atria. This fossa ovale is a shallow depression which is the site of the foramen ovale in the fetus. The annular ovale form its upper margin of the fossa. The floor of the fossa is represented the persistence of the septum prima of the heart of embryonic heart, and the annulus is formed from the lower edge of the septum secundum. It's apart from the embryological terms. This figure show you the position, origin of the septum secundum and septum primum, and the foramen ovale and the septum between the interarterial septum. The arrows of A figure show you the direction of the blood flow, whether it come from the superior vena cava or the other one come from the inferior vena cava. This will decrease the pressure on the lung, the blood flow to the lung. As you know, that embryonic lung are filled with blood without the air. There is no air in the lung. So that there will be pressure of the heart if continue pumping the blood to the lung. So the presence of these foramens will decrease the pressure on the fetus heart. Right ventricle. The right ventricle communicates with the right atrium through the atrioventricular orifice and with the pulmonary trunk through the pulmonary orifice. As the cavity approach, the pulmonary orifice becomes the funnel shape, at which point is referred to as infundibulum. The wall of the right ventricle are much thicker than those of the right atrium and show several internal projection ridge formed by muscle bundle. The projection ridge give the ventricular wall a spongy-like appearance and are known trabeculae carni. This is the trabeculae carni of the wall of the right atrium. Trabecular carni are composed of three types. Number one, the first type comprise the papillary muscle, which are projection inward, being attached by their base to the ventricular wall. Their apex are connected by a fibrous cord called the cordi tendinis to the cusp of tricuspid. The second type is attached at the end of the ventricle wall, being freely in the middle one of these moderator band. Cross the ventricle cavity from one septum to the anterior wall. convey right branch of the atrioventricular bundle, which is a part of the conducting system of the heart. The third type is simple, composed of prominence ridge. The tricuspid valve, guarded by atrioventricular orifice, consists of three cusps formed by fold of endocardium with some connective tissue enclosed, anterior, posterior, or inferior, and septal cusp. The anterior cusp lie anteriorly, the septal cusp lie inferiorly against the ventricular septum, and the inferior or the posterior cusp lie inferiorly. The base of the cusp are attached to the fibrous ring. We call it the skeleton of the heart. Whereas their free edge and ventricular surface are attached to the chordae tendineae. The chordae tendineae connect the cusp to the papillary muscle. When the ventricle contracted, the papillary muscle contracted and prevent the cusp from being forced into the atrium and turned inside out as the ventricular pressure rises. To assist in this process, the chordae tendineae of one papillary muscle are connected to the adjacent part of two cusps. Pulmonary valve differ, guarded by pulmonary orifice, consists of three semilunar cusps formed by a fold. These fold from endocardium with some connective tissue. The pulmonary valve covered the lower margin and side of each cusp are attached to the atrial wall. The open mouth of the cusp are directed upward into the pulmonary trunk. No chordate or papillary muscle are associated with this valve of cusps. The attachment of the side of the cusp to the atrial prevent the cusp from prolapse into the ventricle. At the root of the pulmonary trunk are three dilated regions called sinuses, and one is situated externally to each cusp. The three semilunar cusps are arranged with one posterior left cusp, two anterior right, anterior left. This figure shows you at the upper region the semilunar valve, whether aortic or the pulmonary semilunar valves. The cusp of the pulmonary and aortic valve are named according to their position in the fetus before the heart has rotated to the left. This, unfortunately, causes a great deal of unnecessary confusion. During the ventricular systolic, the cusp of the valve are pressed against the wall during the systolic of the pulmonary tract by out crushing blood. During diastolic, the blood backflow toward the heart and enter the sinuses. The valves are clasped, filled, and come into a position in the center of the lumen and close the pulmonary orifice during diastolic. Left atrium similar to the right atrium. The left atrium consists of main cavity and left auricle. The left atrium is situated behind the right atrium and form the greater part of the base of the posterior surface of the heart. Behind it lie the oblique sinus of the serous pericardium. The fibrous pericardium separated it from the esophagus. The interior of the left atrium is smooth, but the left auricle possesses muscular ridge like the right auricle. This figure shows you the left atrium behind the right atrium. Opening of the left atrium for pulmonary veins, two from each lung. They brought the oxygenated blood through the posterior wall and have no valves. The left atrioventricular orifice guarded by mitral valve. The left ventricle communicates with the left atrium through the atrioventricular orifice and with the aorta through aortic orifice. The wall of the left ventricle are 3 times thicker than that of right ventricle. The left ventricular blood pressure is 6 times higher than that of the right ventricle. In cross section, the left ventricle is thicker, circular, and thicker. The right is crescentic because of the bulging of the interventricular septum into the cavity of the right ventricle. There are well-developed straviculi carni, 2 large papillary muscle about no moderator band, but no moderator band. The part of the left ventricle below the aortic orifice is called aortic vestibule, while the part of the right ventricle below pulmonary trunk called infundibulum. Thicker and bulging into the right ventricle. Mitral valve is guarding the atrioventricular orifice, and it consists of 2 cusps, anterior and posterior. The mitral valve have one structure similar to that of the tricuspid valve, while contain anterior cup is larger than the intervenous between the atrioventricular and the aortic orifice. The attachment of the cord tendini to the cusp and the papillary muscle similar to that of the tricuspid valve. Aortic orifice. The aortic orifice guarded by aortic orifice, and is precisely similar structure of the pulmonary valve. One cusp is situated anterior wall, the right cusp, and called the right cusp, and 2 are located on the posterior wall. We call it left and posterior cusp. Behind each cusp, the aorta will bulge to form the aortic sinus. The anterior aortic sinus gives origin to the right coronary artery, while the posterior sinus gives origin to the left coronary sinus. Arterial septum, interarterial septum into the right and left atria. The septum run from the anterior wall of the heart backward on the end to the right. The ventricular portion of the heart has thicker wall and divided by the ventricular interventricular septum into right and left. Skeleton of the heart consists of fibrous ring in which the valves are attached: atrioventricular, pulmonary, aortic, and continuous with the membranous upper part of the ventricular septum. Conducting system of the heart. The normal heart is contracted rhythmically at about 70 to 90 beats per minute in the resting adult. The rhythmic contraction process originates spontaneously in the conductive system and the impulse travels to the different region of the heart so that arterial contract first and together to each other, followed by later ventricular the arterial contract first and together to be followed by later a contraction of the both ventricles. The slight delay in the passage of the impulses from the atrial to the ventricle allow the time of relaxation, allow the time for arterial emptying the content of the blood into ventricular interventricular orifice before the ventricle contraction. The conducting system of the heart consists of a specialized cardiac muscle present in the situation of node between the atrioventricular node, they call the atrioventricular bundle, and its right and left terminal branch. The subendocardial plexus contains Purkinje fiber, specialized cardiac muscle fiber that form the conducting system of the heart. The cardiovascular cardiac conducting system. Heart function. Primary function of the heart is important is to give energy and to impact the energy to the blood is by metformin. The primary function of the heart is to pump the energy to the blood into in order for it to be distributed through this contraction to the whole body. Cardiac cycle. When complete the heartbeat, diastolic relaxation of the ventricle, systolic contraction of the ventricle. The heart function terminology. The amount of the blood pumped out on the ventricle during one beat is known as systolic or stroke volume, ml per stroke. A number of times ventricles beat per minute is known as the heart rate. Cardiac output Q, SV and HP, 1 millimeter per liter. Together, the number of times ventricle beat per minute, known as heart rate. The cardiac output Q contain what we call the outbreak and heart failure together with the sign SV node and H. The amount of the blood pressure pump out of one ventricle during one beat is known as stroke volume or diastolic. A number of times ventricles beat per minute. Together with SA node and the cardiac output Q, 1 millimeter per minute. Together, the sinoventricular and heart rate give to the volume of the blood pump in 1 minute by one ventricle. Arterial systolic AV valve, atrioventricular valve, opened by semilunar valve and closed arterial node. The isovolumetric conduction, all valves is closed. Rapid ejection, aortic and pulmonary valve. AV valves closed, interventricular pressure arise, forcible out, and the aorta and will emptying the heart from the pulmonary lung. Reducing ejection, aortic and pulmonary valves is opened. So we have rapid ejection, aortic and pulmonary valve, AV valve closed, interventricular pressure force, aortic and pulmonary valve is to open. Reduce the ejection, aortic and pulmonary valve opened. AV valve closed, ventricular pressure decrease. The isovolumetric relaxation, all valve closed, arterial, venous pressure rise from them. Rapid ventricular filling, AV valve opened, arterial pressure greater than the ventricle. Reduction of the ventricular filling, the ventricles continue to fill. The pressure difference between the atrium and ventricle. The AV node in which the impulses is delayed before passing into ventricle. The atrioventricular bundle, AV bundle, which conducts the impulse from the ventricles, from the atrium to the ventricle. The left and right bundle is branches of the atrioventricular. We call it Purkinje fibers, which conduct the impulses to all parts of the ventricle. The electrical system of the heart is regulated, depolarized and depolarized at the atrium and the ventricle during the cardiac cycle. Components of the conductive system: atrioventricular node, located in the bottom of the right atrium near the septum. Cell in the AV node conduct impulses more slowly, so there is delay as the impulse travels through the nodes. This allowed the time for the atrium to finish its receiving finish contraction before the ventricle beings contract. The bundle of his from the AV nodes, ventricular impulses travel through to the right and left bundle branches. These branches extend to the right and left side of the septum and bottom of the heart. The bundles attach these branches extend to the right and left side of the septum and bottom of the heart. These branches allot to form the Purkinje fibers, transmit the impulses to the myocardial muscle. The bundle of this part of the body is important for you so that the branches and Purkinje bundle of branches and Purkinje fibers transmit quickly and cause both ventricles to contract at the same time like the phone tree. The ventricle contract, blood is formed out through the semilunar valve into the pulmonary trunk and aorta after the ventricle is filled. So that the ventricular contract blood is forced out through the semilunar valve into pulmonary trunk and aorta. After the ventricular complete their contraction phase, they relax and the deep and the sinoatrial node initiating another impulse to start. Another impulse to start. Pulmonary trunk and the aorta. After the ventricular complete their contraction phase, they relax and the sinoatrial node initiate another impulse to start another cycle. This is the heart showing direction of air and it's showing you by figure sinoatrial nodes, atrioventricular node, bundle of his right and left bundle of his bundle of right and left bundle branches which lead to the Purkinje fibers. This figure show you the ECG, electrocardiogram. This is one other view. This is another review of conduction system of the heart. P-wave atrial repolarization, signal signal sent from the sinoatrial node through the atrium. QRS complex, left or right, depolarization, left ventricle wall, depolarization. The other one systolic. T-wave ventricular repolarization, Purkinje's from the fiber of repolarization.